This is the final project for Transport Processes 1, presented by Diana, Irlanda, and Manny. Problem 1. The system shown of a heat exchanger handles 0.0567 cubic meters per second of water through the pipe system shown. The total pressure drop between the valves, including the valves, is 110,000 pascals. Both valves are gate valves open 3/4. What size pipe is required for this application? Consider the system to be stainless steel.
First of all, we have to make the global energy balance to discard the irrelevant values. Then, we list the data from the problem that give us and the unknowns we have. The diameter is included in the head loss term, but cannot be solved for directly. As the friction factor also depends on diameter, we have to insert numerical values. And assuming 0.0042 as the value of friction factor, we obtain the value of the diameter to be 0.102 meters. With this diameter, we calculate the area and velocity in order to calculate the Reynolds number. And also, with this Reynolds number, we got the graph to check the assumed value of the friction factor, and we observe is the same value than the assumed. Therefore, the size pipe required for this problem is 0.102 meters.
Water at 20 degrees Celsius is to be pumped through the system shown below. The operating data for this motor-driven pump are as the following table shows. The inlet pipe to the pump is 0.06 meters in diameter commercial steel and 8.5 meters in length. The discharge line consists of 60 meters of 0.06 meters in diameter steel pipe. All valves are fully open globe valves. Determine the flow rate through the system.
First, we perform the energy balance. Then we plot the head and efficiency curves. Assume the highest efficiency of the pump, we give the flow rate a value of 0.004 cubic meters per second. Next, we calculate the area with the given diameter in order to calculate our velocity. Once we have the velocity, we calculate the Reynolds number. As we can see, we have a turbulent flow. Since it's a turbulent flow, we use the following equation to find the friction factor. Following, we calculate the head loss considering the losses of valves and elbows. Once we know our total head loss, we calculate the head using the height difference. Finally, we calculate the work needed in horsepower. Hence, assuming the highest efficiency of the pump, the flow rate for the system is 0.004 cubic meters per second.